All right, so chapter 3 is all about polynomial functions. So you can see the definition of a polynomial here at the top. That long definition basically means any combination of numbers and x's with exponents, as long as your exponents are numbers greater than or equal to 0. Integers. What are integers? They are what kind of numbers? Whole numbers. In other words, things that cannot be in polynomials. I'm going to make a list in red for you. Bad things. Square roots. Why are square roots bad for polynomials? Because a square root is what kind of exponent? How do I write a square root as an exponent? As a fraction. So if it has to be an integer, it cannot be a fraction exponent. So square roots and fraction exponents in general are bad. Negative exponents are bad. Negative exponents are bad because it says our exponents must be an integer greater than or equal to 0, which means they can't be negative. How else do we see negative exponents? If they are not written as a negative exponent, where are the x's located? On the bottom. So that's kind of a side note. X's on the bottom of a fraction are bad news too. So that's really what we're looking at here, just saying what is a polynomial, and if it is a polynomial, the degree, the degree, if you want to make a note down here, is just the highest exponent. And number of terms. Remember, if it's a single term, we call it a monomial. Good morning. If it's a two-term, we call it a binomial. Three-term, we call it trinomial. And after that, we just call it a polynomial, or many terms. Okay? So if we're looking at that list, 1 through 8 at the bottom of this page, let's just first pick out the ones that are not polynomials at all. Which ones have problems? 2. What's the issue with 2? The square root is a problem because it's a fraction exponent, so this is not a polynomial. What else is not a polynomial? 3. Why not? The negative 4 exponent means that's not a polynomial. What else? 4. Because the x on the bottom means a negative exponent. So that is not a polynomial. I'm going to keep scrolling down to the bottom here, which means I'm going to lose what I've written up here, but here we go. The other ones that are not polynomials would be what? 6. Not a polynomial. There's x's on the bottom. There's one more that's not, that I didn't mention in particular. 8. Why not? The x is the exponent. Okay, our exponents have to be integers greater than or equal to 0, which means numbers, whole numbers, right? If x is the exponent, then it is not a polynomial. So that leaves me with, let's see, 1, 5, 7. Those are all polynomials. So we have to name them by degree and number of terms. So for something like question 1, what's the highest exponent you see? 4. So this is a 4th degree. How many terms does it have? 3 terms. So we would call it trinomial. Okay, 5. I don't see any exponents, but what is the highest exponent there? 1, if there's nothing written, so we call it a 1st degree. How many terms? 2, so we call it a binomial. Now, ones like 7, we have to be careful before we name them, and why is that? Because it's in factored form. You can only tell me the degree and number of terms once it's written out fully, multiplied out. So that means in order to get degree and number of terms for 7, what do I have to do with this? FOIL it. So first I FOIL x minus 3 times x minus 3. This gives me x squared minus 6x plus 9. Then I distribute my 5x, which gives me 5x cubed minus 30x squared plus 45x. Then I can say, what is the degree of this one? Third degree, because the highest exponent is 3. How many terms? Trinomial. Now, you cannot tell necessarily that it's going to be a trinomial until you multiply it out. You can tell the degree from factored form. If it is in factored form, you can add up your exponents. So, for example, what's the exponent on that x right there? 1. And the exponent out here is 2. Total, that gives me 3. So if it's in factored form, you can add up your exponents to get the degree, which we're going to see on the next page too. Okay? Any issues with, is it a polynomial, is it not, in degree, number of terms? Like I said, this is a pretty easy lesson for this day, so that's why we kind of land this one here. All right, on the back, we're just going to briefly talk about graphing these by hand. These are not going to be very specific graphs. So really what we have here is degree and roots that help us. End behavior is going to come in here too. It looks a little bit different than we did end behavior for parent functions. So I'm going to explain just a couple things for you here. First, we're going to make a little chart up at the top. Your little chart here is going to be very, very helpful in helping you remember what kind of polynomials are what. So we have odd degree.
For school, please pardon the interruption. At this time, I need all students who are being...
So we can have two things, or we can have even degree. And that's simply whether your highest exponent is an even or an odd number. And then there's something else out here that we call the leading coefficient that tells us the end behavior. The leading coefficient is literally just the number that is out front of the polynomial when it's in standard form written out. If your leading coefficient is positive, it tells us one thing. If your leading coefficient is negative, it tells us another. So what we're going to do is just draw little sketches of your end behavior. So if it is odd and positive, so this first box, the left side will go down, the right side will go up. That's our end behavior for that. Odd, your ends always go opposite directions. So if you have an odd degree with a negative leading coefficient, the left side goes up, the right side goes down. There's like math ways to write this that's more technical, but the visual picture usually helps you graph better. If it is even, both ends go the same direction. Even's the easy one to remember, because if it's even positive, both ends go up. Even negative, both ends go down. Okay, and this is, like I said, the degree over here. So this little chart is going to be like everything for you on graphing. So here's how this works. First, you want it to be in factored form. We're starting easy, starting in factored form for all of these. Okay? When it's in factored form, how do you find x-intercepts? Set each of these equal to 0. Okay, so when it's in factored form, that's easy for you, hopefully. We have 2 x-intercepts on this one. X equals what? 2 and x equals? Okay, so we start by graphing just our x-intercepts. That's the only thing that we're going to count out here, where I actually draw exactly where 2 and negative 3 are. Okay. Then I look for degree and leading coefficient, the number out front, to help me see what the ends are going to look like. If I don't want to multiply this together, how do I find the degree? Add the exponents. That's x to the first and x to the first. There's 2 parentheses, 2 zeros. That means what degree? Second degree. And is there any number out front? No, that means my leading coefficient, which we're going to abbreviate LC, is what? Positive 1. We don't really care that what number it is. We just care that it's either positive or negative. So this throws us in what category in our table here? Even what? Even positive. Because the degree is 2, so that's an even number, positive leading coefficient. Any issues with that? All right, so that tells us what about both ends? They go up. So when I'm drawing a sketch of this, I know that the left side goes up. I know the right side goes up. Okay? Now to finish that graph, how it looks, we have to talk about one other thing, and it's called multiplicities. You have that down in the box down there, single root, double root, triple root. I don't want to erase mine, so you can write that next to these. This is called multiplicities. And it is how many times a root or an x-intercept occurs. Okay? And I'll explain in just a second what these mean. A single root, it simply crosses the x-axis. A double root, the best way to call that is a bounce. And a triple root, it's a slide or an S shape. Okay, so here's where your drawing skills don't necessarily have to come into play too much. I can show you what I mean by that when we have to get into these. Multiplicities involve the exponents on the outside of the parentheses. Okay, so in question 9, do I have any exponents on the outside of the parentheses on either one of those? No. Okay, what we're looking at is for something like in 10, there's an exponent out there. Okay, so what that means is that these are both considered single roots. So a single root, the behavior at that root, you're going to know that from your multiplicities. According to what we just wrote down, a single root simply crosses through the x-axis. So that simply means from my end behavior here, it just crosses through that x and crosses through that x, and it's basically a U shape. But you see what I'm saying? Our graphs aren't super specific. We're going to do our x-intercepts, and we're going to do our end behavior and how it crosses through, and that's about it. I'm not graphing a y-intercept. I'm not finding other points. None of that. Okay? So let's try that again with question 10. First, let's just find the roots of question 10. If there is an x, when an x is out front by itself, what kind of root is that? It's 0. X equals 0. This second one is going to give me x equals what? 4. And because of that squared on the outside, that means literally I could write x minus 4 times x minus 4, right? So what kind of root would we call that? A single, double, or triple? A double. Okay, when it occurs twice, and I usually write a little times 2 back there just to remind myself, that's a double root there. So if I have one root at 0 and a double root at 4, what does that make my degree total? 3. So this is a third degree. And what is our leading coefficient? Is there a number out there? 1 in front of the x, which means our leading coefficient is positive, right? All right, so if it's third degree, leading coefficient positive, that tells me that we are in the odd positive category. So what can we graph so far? Well, I have an x-intercept at 0, and I have an x-intercept at 4. What do we know about the ends of our graph? According to the odd positive, the left side goes where? Down. The right side goes up. So then to finish our graph, I use the multiplicities. 0 was what kind of root? A single, double, or triple? Single, which means at 0, what's the behavior according to our multiplicities? It just crosses directly through. Okay. What happens at 4 when it's a double root? What do we call that? A bounce, which means it literally touches it and goes back in the same direction. So what that looks like on this graph is that it comes up, comes down, bounces, goes right back up. Okay? That's the easiest way to talk about it because it literally looks like if a ball, you traced its path, it's coming down, bounces, and goes right back up. Okay? So that means when you have a double root, you never cross through the x-axis at that point. It stays on the same side. It either stays above or it stays below, whichever one it was. Okay? So let's practice that. I'm going to skip down to 12 real quick, and we'll come back to 11. What did we say about x by itself as a root? Even if it's an x squared. It's x equals 0. The squared means what in this case? Double root. So that has a double root at 0. This one has a double root at what? 4. So if there's a double root at 0, a double root at 4, what does that give me total for my degree? Double and double, 4. So 4th degree. And what about my leading coefficient on this one? Leading coefficient's negative. All right. So this has the same roots as the last one, but we're going to see how it looks different because one of them wasn't double on the first one, and it is double on the second. So I know I have a root at 0, a root at 4. According to fourth degree negative leading coefficient, what do I know about both my ends of my graph? They both go down because it's even negative. And what's the behavior at both roots? Double root, which is a bounce. So that means it does not cross through, it stays on the same side. So what does that kind of look like? As I come up to 0 here, bounces at 0, comes back, bounces at 4, comes back. So it never actually crosses over, it kind of makes an M shape. So just always remember at a double root, it's never going to cross through, ever. Okay? Now we didn't do a triple root yet. We're going to do one of those and then do like one factoring problem and be done. Because once you know how to graph these, it just becomes factoring and then graphing. On question 11, we only have one root here. What's our root? X equals 2, but what kind is it? Triple root. That's a slide or S shape. It's going to look like a cubic, kind of. And because it is to the third power, what does that tell me about my degree? Third degree. What about my leading coefficient? Leading coefficient is negative. Okay. All right, so I graph my root at 2. What do I know about my ends of my graph here? If it's a third degree negative, check our chart up there. Which way does the left side go? Up, and the right side goes down. Okay, so here's where if your drawing skills are terrible like mine are, and you can't actually make it look like a S shape through here, you can always draw a little arrow and just tell me this is supposed to be an S shape. So what that looks like, instead of like a single root, we said it crosses directly through. Instead of crossing directly through, as we get down there, it kind of slides a little bit, makes a little curve shape there. So it's not a direct straight line through it like the single root is. But again, if your drawing skills aren't that great and you have a hard time doing that, this is what you can always do right here. Okay? And you can make a little note. That's supposed to be a triple root there. Okay? I'm never trying to grade you on your drawing skills. So if you know what you're talking about, that's really what I want. Okay? Let's practice that once with graphing on the next page, and then we will be done. So flip over to the next page. The only difference between these questions we just did and most of the ones on the next page is that they're not factored. So something like 14, just look at the difference between 13 and 14. 13's factored form. How do I know? Got all the parentheses and all of that. 14 is not factored form because it's all multiplied out. You need to be in factored form to graph these by hand. So we know how to factor. In question 14, what's the first thing I do to factor that? Take out an x. That gives me x squared minus 4x plus 4. Then we're looking for factors of 4 that add up to negative 4. What are those? X minus 2 and x minus 2, which means how could I write that? X minus 2 squared. Now it's in factored form. Now we can go about the graphing same as usual. So if it's an x by itself, we say it has a root at where? A root at 0, and this is a single root because there is no exponent. This one has a root at where? 2, and it is a double root. We've kind of seen this graph already, haven't we? On the previous page. So we're not going to bother graphing that one because that's exactly the same as I think the second one on the last page we just did. Okay? Let's graph 16. 16 looks like a good one to factor and graph. So what do I take out first in 16? X squared. That's my common factor. Good. If I take that out, I'm left with x squared minus x minus 20. To factor that, I'm looking for factors of 20 that add up to what? Negative 1. Negative 20, yep. Negative 5, positive 4. So now let's go through our roots. Okay, the x squared, that's still an x by itself. That simply means what kind of root? It's a double root at what? 0. Then I have a root at 5, and I have a single root at -4. So we start by graphing our roots. -4, 0, +5. Okay, what's the degree of this one? So you can see fourth degree one of two places. One, back before we factored. That's the highest exponent. Once we factored, you can add up your exponents. The 2 on the x squared, the 1 on the x, the 1 on the x makes 4 as well. So it's a fourth degree with a leading coefficient that is positive or negative? Positive. So since it's fourth and positive, what does that tell us about both our ends? Both go up. All right. Okay, so now to finish this out, let's see what can happen. At 5 and at -4, those are single roots. What's the behavior at the single root? Crosses directly through, so that brings us below the x-axis. Okay. What happens at a double root at 0? It bounces, which means it stays on the same side. So how do I connect this, or what kind of shape is it going to look like? It's going to look like a W shape. Good. Any issues with that? All right, so homework for this, like I said, not due till next Wednesday, is this page. I think this is 237 through 239, 1 through 26. It's 1 through 26 because the beginning stuff is very quick. Because remember, we did do, is this a polynomial, yes or no, and degree and number of terms. So that's the very, very quick stuff on like 1 through the front page. Then there's the graphing. Okay? But like I said, not due till next Wednesday.